This S7 Airbus A310 was on an approach to Irkutsk in Russia. What follows is a result of a poor safety culture in the S7 Airlines, a lack of training for the pilots, and a very big mistake that the captain makes. To see what happens and why, stay tuned. On the 8th of July 2006, S7 Airlines Flight 778, an Airbus A310, was a scheduled passenger flight flying from Moscow to Irkutsk. On board the flight, there were 195 passengers and 8 crew members, 6 of which were the cabin crew, and the other 2 were the captain and the co-pilot. They had a very experienced crew for this flight. The captain's total flying experience was 10,611 hours. His total flight time on the Airbus A310 was 1,056 hours. It's worth noting that for the captain's flying experience, all of the time on type on the Airbus A310 had been as an aircraft captain. He had previously flown on the TU-154 as captain and as an instructor. This aircraft has a 4-person cockpit crew, while the Airbus A310 has a 2-person cockpit crew. The captain then immediately carried out his conversion training to a captain of the Airbus A310, therefore not gaining any experience as a first officer on that type. The co-pilot was also very experienced and had a total flight time of 9,771 hours. His flight experience on the Airbus A310 was 158 hours. 66 of those was as a trainee and 92 was as a co-pilot. So although he was very experienced, he was very new to the Airbus A310. For S7 Airlines themselves, they were still relatively new to flying the Airbus A310. They had started operating this aircraft in July 2004, just 2 years before this incident, and the fleet grew rapidly in the subsequent years. This also meant that the number of requested spare parts for their fleets rapidly increased. However, the number of available stocks was limited. They also had difficulty through customs clearances of importing spare parts from abroad. This led to S7 Airlines carrying out a practice called deferred defects, where they would repair parts of the aircraft with other functioning parts of another aircraft or the same aircraft, and then deferring that defect and extending the time required to repair it. This practice took root in S7 Airlines, and the practice allowed flights with extended deferred defects to continue without any form of control procedure exercised by Russian aviation authorities. For the first 6 months of 2006, there were 86 extended deferred defects recorded on just the Airbus A310 fleet alone. This led to a very low degree of reliability, with there being on average 1 failure for every 23 hours of flight on their Airbus A310 fleet. Comparatively to their next biggest Russian rival, Aeroflot, they had twice as many incidents per hours of flight, and for their safety level of their Airbus A310 had dropped approximately to 4 times lower than that of Aeroflot. For the aircraft in this incident, it had flown 3 days before, and it was flying with a malfunctioning right engine reverser. When it had landed, the reverser on the left engine became inoperative. During the aircraft's maintenance on the next day, the right engine was then fixed with the parts from the left engine, so the aircraft now had a working right engine reverser and an inoperative left engine reverser. So the purpose of the engine reversers is to allow the aircraft to temporarily redirect the engine thrust to slow the aircraft down. This enables the aircraft to land in shorter landing distances and to also assist when the weather is particularly poor and the main braking system isn't as effective. So for S7 Airlines Flight 778, the early stages of flight were fairly uneventful. The passengers boarded the aircraft, they taxied and took off and were in the cruise to Irkutsk. As this flight was in Russian airspace, they use meters instead of feet, so all of the altitude and height readouts will be in meters. They were currently flying at 11,100 meters, and they were cleared to descend to 5,700 meters. At this point, the crew tuned into the ATIS for their destination airport, and the ATIS stands for Automatic Terminal Information Service, and it's basically an automated message which gives the weather for the airfield. The ATIS informed the crew that runway 30 was the runway in use. It was wet 100%. The surface wind was 280 degrees at 4 meters per second. Visibility was 3,500 meters. There was weak showers, complete cumulonimbus at 170, and the temperature was 11 degrees. The captain was happy to continue with the weather conditions and asked for the auto-brake system to be set to low. The crew then continued on their approach and set up the aircraft for landing. During the approach, they deviated slightly left and right of track, but they were brought back on by the controller. They were cleared to land on runway 30, and shortly after, they appeared below the cloud base, which was now at 190 meters. The crew then continued their approach, and at a speed of 132 knots and 200 to 300 meters from the offset threshold of runway 30, the aircraft landed. Immediately after touchdown, the spoilers were automatically released, the auto-brake system was activated, and 1.5 seconds after touchdown, the reverse thrust for the right engine was moved to idle by the captain. 3 seconds later, the captain then switched to maximum reverse thrust. The aircraft was now starting to slow, reaching about 98 knots. The captain then decided to reduce the maximum thrust of the reverser on the right engine and bring it back to idle. As he did so, he placed his palm on the thrust lever for engine number 1, and as he reduced the reverse thrust on engine number 2, he started to increase the thrust on engine number 1. Both the captain and the co-pilot were unaware of this increase in thrust on engine number 1. Because the thrust lever had been pushed further than 10 degrees, according to the logic in the aircraft, this caused the automatic retraction of the spoilers. And with the retraction of the spoilers, this led to the deactivation of the automatic braking mode. The aircraft now started to experience large asymmetric engine thrust, and the aircraft started to veer to the right. The airplane captain then counteracted this by depressing the left pedal to its maximum position, counteracting the asymmetric forces. The captain then depressed the brake pedals to its maximum limit in an attempt to slow the aircraft down. The left engine was now producing about 60% of the thrust that it usually would for takeoff. With the maximum braking that the captain was applying with the foot pedals, the aircraft stabilized around 98 knots. The crew now received a master warning for wrong takeoff configuration. This warning is usually blocked for landings. However, because of the retraction of the thrust reverser, the location of the aircraft on the ground, the speed more than 70 knots, and the position of the left thrust lever, the aircraft logic now believed it was in a takeoff and issued the warning because the flaps, slats and stabilizers were in the wrong position for takeoff. Both the crew members believed this warning was false, and the co-pilot spent a considerable amount of time trying to clear the warning by depressing the clear and recall buttons, but the warning just kept coming back. It was also standard operating procedure for Russian airlines during domestic flights to provide a landing report to the controller. The co-pilots did report the landing, but this, along with the warning, distracted him from his primary job of monitoring the instrument indicators for the engines and the airplane speed, which he had not reported to the captain throughout this approach and landing. It was only as the aircraft had about 800 meters of the runway remaining when the co-pilot reported RPMs increasing, and the captain responded by saying, "Reverse once again." The co-pilot then increased the maximum reverse thrust on the right engine, but because of the position of the left thrust lever, the right engine remained at idle forward thrust. In their confusion, the captain then says, "Why?" And the co-pilot responds, "I don't know." The captain then orders to shut down the engines, but at this point it was too late. Still at a speed of 98 knots, the aircraft left the runway and impacted a row of private garages nearby before finally stopping but bursting into flames. The chaotic scene combined with the darkness caused by the smoke and fire made the evacuation process difficult, but within 65 seconds, 67 passengers were evacuated by the cabin crew. Overall, 75 passengers and 3 cabin crew survived, but unfortunately 120 passengers, 3 cabin crew and the 2 flight crew were all killed. In the aftermath of the crash of Flight 778, investigators sought to determine the cause of the tragedy. Reports initially pointed to mechanical errors, with the brakes being the primary focus of scrutiny by the media, but it was discovered that the captain's hand had inadvertently rested on the left engine's thrust lever as he reached for the right engine's reverse thrust lever. The The force applied was small, but enough to move the lever forward, increasing the left engine's thrust, whilst at the same time decreasing the right engine's reverse thrust. Normally, moving the thrust lever would require significant force. However, the investigation revealed that the coupling that linked the thrust lever with the engine control had weakened over time, reducing the required force needed to move the lever by up to 400 grams. The most concerning aspect was the irregularity of inspections for the thrust lever's friction forces. The logbook for the aircraft involved in the crash did not indicate any inspection or correction had ever been carried out. The European Union Aviation Safety Agency did not consider this issue an airworthiness problem, but it was a clear indication of the lack of maintenance and attention given to this critical component. Another aspect was the training that the pilots had received with reference to landing with reverse thrusters inoperative. It was written in the S7 Airlines minimum equipment list that explicitly stated that if one of the thrust levers was inactive, the pilot should hold the lever in the idle position to prevent any accidental forward movement. The crew did not receive any training on exercises on landing with one deactivated thrust lever, and according to the airline, it does not train its flight crews to develop these skills. During the simulations in the investigation of this incident, it was revealed that the bumpy runway at Irkutsk may have played a part in the accident. The movement of the lever during the landing was not easily noticed due to the shaking and deceleration of the aircraft. Despite this, the co-pilots should have been monitoring the aircraft instruments and aircraft speed during the landing, and if this was done correctly, this incident could have potentially been prevented. One other aspect, not relating to the cause of the crash, but to the detriment of the evacuation, was that when S7 purchased the Airbus A310, they requested that the layout be changed from a 3-class layout with 185 seats to a 2-class layout with 205 seats. One thing that was not changed during the adaptation was protective breathing equipment. This meant that there was no breathing equipment on board for the 2 flight attendants responsible for the emergency exits in the middle part of the cabin. Additionally, the breathing equipment for the flight attendants in the tail section of the cabin was located on the wall at the side of the passenger cabin. This did not allow for flight attendants to quickly fetch it if the need arose. The main cause of loss of life in this incident was carbon monoxide poisoning, and it may have assisted the evacuation if the flight attendants had the correct training and equipment to allow for a quicker and more effective evacuation. The investigation concluded that the cause of the crash was due to the captain inadvertently and uncontrollably moving the thrust lever on the left engine from the idle position to a significant forward thrust position, whilst trying to remove the reverse thrust on the right engine. The co-pilot's inadequate monitoring and call-outs of the airplane's speed and engine parameters made it impossible for the crew to perform the necessary actions to recover the aircraft in time. There were several safety recommendations as a result of this investigation. To the aviation authorities of Russia, they were to carry out a comprehensive analysis of the specificities of operating airplanes of Russian and Western manufacturers. They were to develop and implement a universal course for improving the qualifications of flight crews specializing in crew resource management on airplanes with 2-man crews. They were to cease the practice of granting permits to carry out flights with a prolonged period of correcting faults without a detailed analysis of each specific occurrence. For S7 Airlines, they were to cease the practice of training captains on aircraft of Western manufacture with 2-man crews without passing through co-pilot training courses and gaining experience on operational flights in this capacity. They were also to devise a course for the initial training of airline instructors and to correct any other faults that have been revealed in the course of this investigation, as well as during an audit conducted by Airbus in April 2006. It was also recommended that the use of reverse thrust on a single engine be paused until the Airbus group have developed a unified procedure for engaging reverse thrust, irrespective of the engine type or the presence of a deactivated thrust reverser. And for the International Civil Aviation Organization to examine the question of urgently introducing the video recording of any situation in the cockpit as an ICAO standard. Please let me know in the comments down below what you think of this incident. I do read all of the comments, and I thank you for everyone that comments and engages with me so far. I hope you enjoyed this video, and as always, I'll see you in the next one.